everyone. We'll continue the discussion related to the operating systems. So, when it comes to program execution, we are required to have a set of components. So, if in any case, if these components are not in the computer or these components are not working properly, there might be a problem. We'll see what are the components. The first one is processor. In any given case, the processor is not working properly, or in any case, there's some sort of defect in a processor or malfunctioning, programs would not execute. The second one is main memory. Main memory is one of very important component in a computer that helps to execute the program. In any case, the main memory is not working properly. Simply, you may think it's just your RAM. In any case, your main memory is not working. Your computer would not work properly because programs would not execute. Because once it comes to a program, accessing to the main memory is a must. Without accessing to the main memory, none of program can access to the processor. So it's very, very important your main memory is working properly and sufficient space is available. Once it comes to I/O modules, input and output modules. In any case, the I/O responses or threads or execution components are not working properly, then it would not work, the program would not work. I'll give an example. Now think your keyboard is not working, your mouse is not working, or some external peripheral, it's not working. So the required activity, the required program would not execute. Now I think you can remember that we spoke about this process diagram. In that case, we know about that the starting is in here, then it moves to the running to state, and here this is the state that we stop for a while. It's just stop for a while until the IO completion. So usually it's an IO completion. So this is the place that IO modules come into the scope. So you know, this is process diagram, this is date, and it's running and timeout and other stuff. System buses. Now these system buses performing lot of help for us. Now we'll go to each of component and understand a little bit more detailed about this processor, main memory, IO modules, and system buses, and what are they, and what are the main purpose, or simply what are they, and what are the main purposes of these components in a computer. So in any case, in any of component is not working properly, the program would not execute properly. So you should have good understanding on that. To start with processor. Processor, usually you might heard this word, central processing unit. Now once it comes to in a computer, it's an embedded device and it's inside your motherboard. Motherboard is nothing, it's just the computer entire layout that you can find in a computer. In laptop or a desktop, there's a big electronic circuitry board which is connected to a lot of capacitors, transistors, and so on and so forth. So this processor is such kind of a device that embedded or plugged into this motherboard, and it provides the processing activities. In any case, this central processing unit or the processor would not work, means the entire computer would not work. Machine that process something. If we get in this understanding, what's a processor? It's a machine that process something. It might be very important task, or it might be less important work. Regardless of the situation, whatever the instruction comes to the processor, it processes it. That's it. I'll give an example. Think a situation that you are typing something in a word processor. In this case, you have opened your Word document. It might be Google Doc. It might be your Microsoft Word or LibreOffice or something. And in the other hand, you are typing. None of the time the processor would sleep or wait until the next one would not stop. It continuously process. That means it continuously process what are the processes related to the Word document could be open. It might be in your browser or it might be in your software. As an example, if it is a Google Doc, that means you have your processor executing continuously instructions given by the web browser. I want do and this and that. As an example, connectivity, data packets transferring, spelling checking, lot of things might be. And in the other hand, if it is Microsoft Word, you might see the similar kind of thing. So this is that a machine that providing some process related stuff that we have to do. This is the part of computer which operations are controlled and executed. Now, once it comes to execution process, you might be able to understand, oh yes, it's quite easy. Once it comes to controlling means what are the instructions that we would execute in here and there. So once it comes to like lot of instructions from different sources, it might be from your primary, it might be from secondary IO device or something. So whatever the instructions comes into this CPU, it controlled and executed. In any case, something is not working. As an example, the keyboard is not working and you are trying to type something. There might be some message, your keyboard is not working, or beep sound or something. Sometimes it might be nothing, it's just keep quiet. Somehow it's a controlled environment. So this CPU performs these controlling activities. Controls the operations, mathematical operations. As an example, 8 plus 2. What's the answer? For you, because you have used these 10 values. But once it comes to computers, computer would not understand 8, 2 or plus or enter. What computer understood? It understood 1 0 1 0 1 0 1 1 0 1 0 and 1. So whenever we are providing some instruction to the computer, as an example 8, it converts into binaries, and plus convert into binaries, convert into binaries. Once you press the key enter, or simply if you want to get the output, it performs another set of series of 1 zeros. It executes another series of 1 zeros and provide output as a series of ones and zeros. But what happens? It converts into a decimal value. Then that's the value that we could understand. That's the value that we could understand. So that is the most important thing that you should understand. Well, what's a process? An execution of standard set of instructions. An example, here a web browser, a mouse, simply a click, or it might be your entire screen, or simply your keyboard typing, whatever the situation, or simply connected to the internet. Whatever the situation happens in here, it's an execution of standard set of instructions. Now here your web browser requires to perform a lot of execution instructions. What are some sort of examples? Some of examples are it required to process browser image, browser text box, right, and standard GUI, and behind the scene, the network connectivity, how the data packets are transferred here and there. So a lot of activities are doing behind the scene. Most of the thing because we don't want to touch it, we don't want to experience what happens inside. We just want to type something in here and get the output. That's it. That's all our requirement. But once it comes to computer, the internal situations, it required to understand all of the situations. As an example, in any case, this icon is not further given, so it should update it properly. Behind the scene, it's happening. We can't find it. As an example, after a while, currently you might see your Facebook logo converting into meta text and other stuff. Meta logo. Why it's happening? Because behind the scene, these things are happening. If it's your mobile phone, it's an operating system again, isn't it? It's another operating system. So simply you should understand, okay, a process is an execution of standard set of instructions. These instructions are predefined. As an example, if it is your mouse, it clearly defines what this mouse can do. This mouse can perform a left click or a right click and scroll it here and there and move into XY axis. Based on these coordinates, it can identify the location where this mouse actually locates. And according to that XY coordinates, once it comes to coordinates, the screen, the mouse pointer points to the exact place that you want to point it. That's the instruction, the predefined standard instruction. By using your mouse, you do not supposed to watch a movie, isn't it? Enjoy with the music. No, there are specific instructions or specific items are there. These items has specific instructions. Based on these instructions, everything happens. Similar for the others too. So I think you got the idea about what's a process. It's just nothing. It's just something that execution of standard set of instructions. It's set of instructions. If you learn a little bit further, you can write these instructions by using machine languages and low-level languages. I'm not going to that detailed because this is not a computer science course. So, but you can understand if you really interest, you can go a little bit further and you can understand how to write these kinds of processes. We have understood what's a processor. Next, what we need to understand the memory or the main memory. Main memory, you might see different places these two names also, real memory or primary memory. So regardless of the name, everything refers to one thing. That's the main memory. It is a hardware device that is located internally. So simply again, this component, I'm pretty sure at least few of you got this experience. You touch one of main memory, and you should find what are the slots in main memory, how to plug this main memory into a motherboard. There are separate slots available, so you should understand what's the slot and you can plug it. Once it comes to current business world, most of the cases, once it comes if you have warranty and other stuff, you should not open and do these operations unless if it is required, because in any case, if you open your laptop or your machine, the warranty might not valid after that. So if there's no warranty and other stuff, you can enjoy, you can plug in and do some kind of experience, get some sort of experience by plugging and other stuff. So what's happening here? It's main memory. It's just a place for execution. That's a hardware device that is located internally. So simply, if we more specified it, it's located in the motherboard. The main purpose of main memory is store data and programs. Now, once it comes to storing data, your main memory might be 8 GB. So what's the purpose? To store your movies and audio files, word documents. These kinds of documents do we store in the main memory or not? What's your idea? Do we store movies, videos, audios, word documents, or any other stuff, pictures, whatever? Do we use our main memories to store that kind of data? Any ideas? Yes, quickly, please. My question is, can we use main memory to store audio files, video files, pictures, etc.? Simply yes or no. Anyone? No? No idea at all? If I state yes, I can store my movies because I have 8 GB of storage. My RAM is 8 GB. So I'm going to store my movie, one of latest movie. Yeah, I got one answer, no. Any others who accept my answer? I'm going to store my movie in my RAM, one of movie, the latest downloaded movie. I'm going to store in main memory. What do you think? Can we or can't? I got one answer, no. Anyone agreed with my answer? Anyone is willing to store your movies in RAM or main memory? Come on, guys. Right. If you don't have any answers, I have converted into a question. Probably that makes sense. By after completing this question, you can get 1 point, 2 points for this in class activity. All right. I will give 2 marks. Collect these 2 points. Don't lose these points. My experience is the students who are getting highest points having the highest marks. So collect these points. That makes your life easier. So I'll share it, everyone. Yes, everyone in the meeting. Start. I will give a couple of minutes to answer this question. What happens if your answer is incorrect? No worries at all. You will get your 2 points. Whether it's correct or wrong, no worries. Just the engagement is required. All you need to do is you need to provide your answer, your thought. It might be wrong, it might be correct. No worries. Though it's correct or wrong, your 2 points will be collected. It might be added to your marks. We'll give another minute. Right. So I think that's more than enough to answer. I'll share my screen and we'll see the responses from the students. Yes, there's a question. All right, no worries if there's a power cut, no worries at all. Uh, if you want, you can connect with the mobile phone uh, and you can engage with these activities. There, most of the cases, I think Google Forms are working perfectly, even with the mobile data. If you like, if there are some sort of interruptions nowadays, you can go through the video recorded in here. That's not a big deal. My expectation is to engage these things, and I'll keep the link enabled. Don't worry, you may answer it later on, but it's your responsibility to attend and answer. These activities are doing for you. All right. Well, let me share the screen with you. All right. Operating systems. Okay. All right. Now here. The question is, Mr. ABC state that he can store video files in main memory. Do you agree with this statement? Argue. Now, this person is telling that he's going to store a movie or a video file in main memory. Now, once it comes to this kind of question, how to answer it is quite important. Are you agree with this statement? Now, at the first line, you should say whether you are agreed or not. As an example, the first student, no. Second student, yes, yes, no. Now for this student, there's no yes or no. At the beginning, there's no any yes or no. But some sort of interpretation is in there. So once it comes to this kind of answer, you might get a little bit lower marks because you might get only for the argument, not for the first question. There are two parts in this question. Are you agreed with this statement? Then you have to say yes or no, simply. So for this, for students, done it. No, yes, yes, yes. Yes, yes, no. For the student, no. This kind of answer is okay. No, I don't agree. That's okay. Simply you can say yes or no, or something like this. And the next part, you should argue. You should confirm why you are stating the yes or no. Now, for the first student, state no, so it's not agreed. I think we cannot store the films in main memory. So the answer is like big ambiguous. I'm not sure. I think we cannot store films in main memory. Instead, now this kind of answer is quite ambiguous. The student states, I'm not sure whether this answer is perfect or not. Once it comes to answering, you should perfect. You should stay. All right. I confirm because you stated no. Now I'm going to argue. I'm not. Uh, I'm not agree with Mr. ABC because I don't. This thing I don't know. We cannot, or the any end user cannot store the films in main memory. Nor in this, I think this additional word makes terrible experience. Sometimes you might get a little bit lower marks. For these two students who answered just yes, might get very low marks because no argument at all. Once it comes to this kind of a question, your argument is very important because sometimes there might be open-ended. Based on the argument, your answer can be true or false. But in this case, you can't because it's specific. But some of questions in your university life, you might find this kind of a question. Then you should confirm based on your argument. Sometimes it might be yes or no. Now this guy, no, no, he can't. Got the point. Now that kind of a thing is no, he can't. No argument at all. We'll get this answer. I don't agree because now the student is specifying because my argument is the files are usually stored in secondary memory. Main memory is used to store data temporarily or temporarily used by the processor. So this kind of answer is more than enough for a small argument. It's like very small argument, but it's like compressed and shrink and given the key point that required. So this student might get around, if it is like 80% of mark from the weight of this. As an example, if there's 10 marks for this question, the student might get around 8 marks. So a pretty good attempt. You should find now somehow. What is the answer? Mr. ABC can't store video files in main memory because main memory is used by the processor. We can't store anything in main memory. If we want to store something in if we want to store a movie or a document or any other digital asset, we have to use the secondary memory, your disks, to store those information or store those files. We can't store as it is. We can't store any movies or documents or anything in our main memory. Got the point? Anything else? Any arguments that you have further? I haven't gone everything, but I have gone up to some extent. Most of the students done well. So as an example, main memory capacity is less than, no, it's not. So this kind of argument is not. No, that's correct. But main memory temporarily store data files and capacity is less than the secondary memory, where it is unable to store video files. That's not the reason. That's not the reason. And here, main memory is volatile storage, which is erase all the power failures. So this student argue because if we store a video, that means after computer shut down, this video might not in there further. So it might be deleted. So it won't happen. Simply you should say no, you can't perform this kind of activity because primary memory is only focusing for processing activities or support for the processor. If we want to store anything, we have to use secondary. Got the point? Now these students also same thing. I don't agree, that's fine. This is volatile device. So after power, data will lose. No, not at all. Not at all. But this one is nearly okay. Main memory is for store information for immediate use. Now, this is incomplete. Immediate use, you have to state where or who or from or something. This is like center segment in here. Is some missing part. Main memory is for store for immediate use by the processor. That's the missing component. Clear? All right. Any other things that you want to specify? Anything else? I think fine. The main purpose of store data. Now, what are the store data then? What are the things that this main memory is going to store? The instructions or the programs that ready to execute. The next time it's going to execute. It's like temporal storage. As an example, your parents, I'm pretty sure still your parents are bringing vegetables, fruits, and other stuff. Once your father bought these vegetables, he kept in a refrigerator. Here it's like long-term storage. Early in the morning, your mother took the stuff and kept in a table and cut it and do processing. Then only she starts cooking. Then only she starts cooking. Here, this is the secondary storage. Here, this is the primary storage. Primary storage is your desk. Here, this is the place that processing or cooking. This is the place that processor. This is the processor. This is like for long term. Now, your father could not keep all the thing in your on top of your kitchen table, right? Then your mother will start hey, what you are doing, man? Keep somewhere else, isn't it? Your mother will get angry. But I know personally, fathers would not do. Fathers directly give into the mother's hand. You do whatever the things that you want. Keep in any place that you prefer, because fathers do not want to burn their hands. That's the reality. For some reason, think the stories. This is the secondary storage. This is for a long term. Your refrigerator is like your fridge. Your fridge is for long term storage, and your mother took it out and process it. It stores the data, yes, of course, but for processing, for next cooking item is going to be there. There are 10 vegetables in here, but your mother took only two or one or two that required to process today. Then your mother starts cooking. The stuff here from the refrigerator, we do not put it to the cooking, right? Directly. We have to cut it, chop it, clean it, and process it properly. Got the point? Now, this is the main memory. This is the secondary memory. This is the processor. It's a volatile memory. Well, main memory is volatile memory. Volatile memory means if any case, if there's a power failure or power is not continuously uh, given to the main memory, the data that's stored will remove. As an example, your computer shut it down, so none of information will kept as it is, everything will lost. And after next start, your computer has a fresh data storage. So all the stored data is removed. Now someone can now you may think a situation, if there's a corrupted, your computer is not working for some reason, as an example, your computer is not working, stuck, your cursor is not moving further. Now nothing we can type. Now the computer is corrupted. What you usually do, you start to refresh it, unless it might be a restart or a shutdown. What happens in here? After restarting or a shutdown, your primary memory, there are a lot of information in here. There are a lot. Now you're shutting down. Okay, no more power. No more power. Every data that stores in here will delete it. It's not furthermore. Now, the next time you're starting your computer, it has a fresh space or a clean space to execute the data. Hence, now reset all, you can continue. Got the point? You got the reason why we are using this kind of a volatile memory for processing, and the importance of this volatile memory. If it is a secondary storage kind of thing, it's a big mess. We can't perform this kind of activities. We discussed two components, processor and main memory. Now we'll move to I/O modules. Move data between the computer and its external environment. I/O modules are focusing on moving data between the computer. In here and there, it takes the stuff and put into some another required place. And its external environment, somewhere that we can use externally, not connected to the motherboard, simply not connected to the motherboard. That's all we are speaking in here. External environment. That means we can plug in and use it. As an example, secondary memory, like USB drives, communication equipments such as speakers, mics, and other stuff. So all of these are focusing on data transfer in here and there. All right, clear? Any questions? Simply, this is like an IC actually. It's not one IC, it's a set of ICs, but these are specific to like provide some sort of interface. Input output. Very simple, it's not a big deal. Clear? All right. That's all right. It's not a big deal to understand IO. System buses now. So once it comes to system buses, there are a lot of information to learn, a lot of things to learn. But I will give very high level and the most essential understanding regarding this system bus. It provides communication among processors, main memory, and IO modules. Now, there should be a communicator or a coordinator or take the information from one place to another place. As an example, think your refrigerator is located in 1 kilometer away from the kitchen. It's a big deal, right? It's a big deal. Now, you need a guy who takes these vegetables to your home, or simply you might think the processed foods. As an example, bread and other stuff. There are three-wheelers carrying these kind of bread, buns, and other stuff. Why? It took from the processed place to the consuming place. The place that process it or bake the items, then it delivers to specific home or required place. It takes the data, bread. Similarly, in a computer, it took different places, different buses to carry. Simply, you can understand what happens in a bus. Now, you are in Gaul and you want to travel to Morocco. Gaul to Morocco. Now, you jump into a bus because this is a boy. Jump into a bus, then enjoy in the footboard, and finally drop from a place in Rotterdam. It's a bus. It took yourself from one place to another place, the starting place to ending place. Similarly, once it comes to computers, it requires to do a lot of data transferring here and there. Mainly, there are three buses: control bus, address bus, and data bus. So, in one single word, we can state it's a system bus. So, what happens here? It took data from CPU to the memory to the IO devices, from CPU to the main memory, and it might be input and output devices, or it might be CPU to memory, input output. So these are the responsibilities in very high level. These are the responsibilities of this system bus. So it transfers data. These are the communication channels that provide. These control buses has set of responsibilities. Address buses has another set of responsibilities, and data buses has some set of another responsibilities. So these having their own responsibilities, what kind of data can be transferred? I'll give an example to understand. I don't know. I don't want to go detailed about this. I think you can learn about these technical terms, but in very simple terms. Now, this is a highway bus, and this is a normal road bus. It has their own responsibilities to carry the people and different features available based on the bus. Got the point? Now, these are the system buses. It took the data from one place to another place. Because whenever data to be processed, whenever there's a requirement to process the data, CPU is the place that executing almost everything. Without accessing memory, no point. Without getting some sort of input and output, again, there's no much value. Clear? Anything? Any further information that you required? All right, we have completed almost everything: processor, main memory, I/O modules, and system buses. Any questions? Any further questions to discuss regarding the today discussion? No. All right. Regarding your assessment again, sorry, I'm pressing you, said it. No, it's not a press. I just want to confirm some things, some few things. If you go to the model, not sure for some reason whether it's communication issue or something. Just let me check recently something. Quickly check. Yeah, well, for the group number 8, I can't find a group leader. What was happened? There's no group leader in the leadership, or something gone wrong, or the group leader missed to enter your name. Yes. Any idea? Updated? Well, still not. Group 8, Lakshani, Jayani, Ravindu, Yasaru, Sahan, Amodi, and another guy who do not have a name. Could you please update your group leader earliest as possible just now? You can access the link. Quickly, one should take the responsibility. Updated? Still not. Still not. All right. Then I will deduct 5% from this group 8 Since there's no any leaders, if you can't take a leadership, I'll deduct 5 marks from the group 8. All right, done. Well, now next thing is you should create a video, right, and the document. Now, once it comes to video, apart from the recordings that you should upload, what you should do is you should perform it in class. I will give half an hour for each team. So altogether there are 8 teams. So you can decide when you are going to present, right? That means next week 4 teams going to present, and next week in the sense wait. First, right? July 1st 4 teams going to present, and July 8th other 4 teams going to present your reports and what you found and related stuff what you have done. Today I need a confirmation who are the people going to present next week, July 1st, and who are the people going to present in 8th. Could you please update presentation date? All right. Presentation date. There are 2 dates available. 1st of July, and next date is 8th of July. You can decide with have a discussion with your group, and you have to state when you are going to present. 4 teams going to present 1st of July, then 4 teams going to present 8th of July. You can decide. I'll give around a couple of minutes. Earliest as possible, please update. Anything needs to clarify? මොනවාරි තේරුම් නැති දෙයක් තියනවද? උඹලට ප්‍රසන්ටේෂන් එකක් කරන්න තියෙනවා. ඒ ප්‍රසන්ටේෂන් එක කරන්න වෙන්නේ රෙකෝඩින් එක කරන්න ඕනේ. රෙකෝඩින් කරලා අප්ලෝඩ් කරන්න ඕනේ. ඊට අමතරව ඉන් ක්ලාස් ප්‍රසන්ට් ඒකම ඉන් ක්ලාස් ප්‍රසන්ටේෂන් එකක් විදිහට ටීම් එක එකතු වෙලා කරන්න ඕනේ. ටීම් 4ක් ජුලයි 1st week 1st කරනවා. තව ටීම්ස් 4ක් ජුලයි 8th කරනවා. උගලන් ඩිසයිඩ් කරන ටීම් එකත් එක්ක කතා කරලා 1st කරනවාද 8th කරනවාද කියලා ඉක්මනට මට මේ ෂීට් එක අප්ඩේට් කරලා දෙන්න. For the recordings, you can decide what is the tool that is for me. You can use Teams, Zoom, any medium. You just log in together and start recording. For that case, for in-class presentation, you have to share the screen in your slide in your end, and you can start presenting. Or one student can share entire screen, and others can start presenting. You can decide whatever the method that you want, but it should be a very smooth presentation. As an example, one person starts presenting and don't know who is going to present next. In such cases, you might lose your marks. So take this serious and prepare well. And I need a neat, clear, very detailed presentation. It's half an hour. So one team half an hour. That means one student can speak around 3 to 5 minutes usually. Already 2 teams allocated for, there are 5 teams. No, we can't allocate 5 teams. 8. You have to decide it. Jan, you're too late. I have already done the marks for you. It's too late. No point to add this line. I have removed it. Almost everyone is going to present 8. Not at all. Come on, quickly. 4 teams should be July 1st. You know why I'm telling to find a proper leader? If we didn't find a proper leader to lead us, that means there's a big mess. In the entire history, there are sufficient evidences. So you should select or pick the most strongest leader who can help us, not to rule us, to help us. So it's your responsibility to find a proper leader. It's compulsory to create from more than one question. No. One is more than enough. One is more than enough. One question is more than enough. If you are going beyond that, you will get a plus point. But during the class, you should select one topic only. The other topic, you can present it and record it and upload it. It's a plus point, and there are added marks for that kind of extra one. If you are doing more than one, that means 2 or 3 topics, that's really good, and you'll get like additional bonus for that. But it's not mandatory. All right. So group number 1. Group number 1 will next week, July 1st. July 1st. Yes, any questions? Yeah, for the in-class presentation, you have to select only one. But for the recordings, you can discuss more than one question. All right, one group selected July 1st. Here, the other group selected July 1st. All right, 2. Okay, well, that's fine. I think 8, then entire day. 1, 2, 3, 4, 5. Do we have sufficient time? Yeah, we can. 1. So basically what happens, group 2, we'll do coloring in here. 8. July 1st. All right, notice we have only selected 5 teams for 8. I think that's perfect. All right, 8 perfect. So group number 1 and group number 4 and 5 going to present next week, and rest of the teams will present 8. All right. I fill a color 8. Yes, fine. Okay. All right then. We have selected perfectly. I think that's perfect selection. 1, 2, 3 teams. Yes. 3 teams going to present next week. So prepare your presentations and present it well, clearly, and it should be detailed enough. Each one should present. It's a mandatory case. If any case, if someone is having a power cut, please do the relevant movements. As an example, if you are not sure, you can do the presentation your mobile phone. Please go someone who can help you. One of friend around you. I'm pretty sure you should have some friends, isn't it? You should have. You are going to help people now, so you should work with people. So until A levels, you can be a bit what we call selfish and do learning. But once it comes to graduate level, you should be much friendly with everyone. So now it's time to go out. If there's any power cuts and other stuff, please do not come by stating there's a power cut, there's this kind of issue, there's an accident, my father died, my grandmother died. Like, your school time fake information is not much strong for me. Okay, please make sure to ready it well and do the best presentations that you can do in class. You don't want to switch on your video during the class. That's not required. If you do, that's fine. I don't mainly consider about that. I just consider about the content and the clarity and the ability to work as a team, especially the coordination. Who is going to present first? What are the information? Second, there's a flow. Someone should understand it. What happens in here and there. Got the point? Clear? Any questions? Anything needs to clarify? So Uresh, Kabli Shikha, and who is that? Mayuni. Yeah, Mayuni, please prepare your team and drive towards the success. So other team members, please help to the team leader and have wonderful, amazing presentation. Right? It should be outstanding and best performing presentation that it could be. Any questions? No other questions? Everything is cool? Yeah, there's a question. We'll see what is the question. No? All right. So, right. Then that's it. We'll go to our discussion again. Well, all right. There are a set of questions that I am going to share with you. Yes, questions. Wait. I will give 2 minutes to you. Start answering earliest as possible. Don't take a lot of time. This is a kind of a simple revision that yes, this is a simple revision. It's very valuable for you. Don't worry if something gone wrong. No marks deducted or no points deducted. You will get the marks as it is. Answers might be correct or incorrect, no worries. In involvement is the only consideration. Okay, I will give 10 minutes and or 10 or 12 minutes around if it is required. Meanwhile, if you have any individual question, your personal information that required regarding the subject or adjustment or any other thing, feel free to chat with me, or you can switch on your mic and speak with me, whatever the method that you preferred. No worries, you can share that information. You can ask the question. I will give another 2 minutes to answer. I think that's more than enough. Do you want more time, students? Do you want more time? Yeah, still I got only 18 answers. What about the others? Quickly, others. Do you want more time? I got only 21. I just need at least 25 answers. Please submit your answers quickly. All right, thank you for the answering. I got 26 answers now. Thank you. So, well, 27. Good. Now, all right. Before the, right, no, we'll do this one first. Mhm. All right. All right. 28 responses. Thank you. So we'll see. The questions given in here. The first one lists down 3 operating systems. Like what sort of operating systems? It's quite easy. Windows, Linux, Mac, Windows, Android, good. Windows, Mac, Linux. So most of your answers are good. And yeah, now when it comes to 3 operating systems, uh, you may go to like Windows, Mac, and other stuff. If you go to Linux, Ubuntu, Parrot, that means like Ubuntu and other, these are flavors of Linux. So no one can say it's incorrect, but give some sort of like this kind of like very discrete like operating systems. Then that makes easier. Okay, good. What is an operating system? An operating system is a type. An operating system. An operating system is. Let me take this one. An operating system is the program that handles all programs after being loaded into computer by boot program. Very good. Which is our next topic, the booting. Well, that's good. Okay. Take another example. An operating system is the system software that being initially loaded into computer by a boot program, manages all of other programs in a computer, or it is system software that acts as intermediate between liveware and hardware. All right. So yeah, any questions? Hiranya, Hiranya, any questions? No. All right. Well, here the program that after being initially loaded into the computer by boot program manages of all of blah blah blah. Okay, okay, very well, good. Most of your answers are quite nice. Some of students copy pasted, no point at all. I just want to uh, tell your own words. Always, your words are value. It has some sort of value. And here, like operating system is a system software that manages computer hardware, software resources, and provides command services for computer programs. It acts as interface between computer. This is like you can understand, right? It's in this sentence is everywhere. Means it's like copied from somewhere, isn't it? It's copied from somewhere. Please avoid these kinds of. These are academic misconducts. Write in your own. It might be very smaller answer, not a detailed answer. That's fine. It's your words. Whatever you understood. Here, an interface between user and the hardware. It's like it acts interface between computer hardware components and the user. An interface between the user and the hardware. You can understand, isn't it? So good. Overall, it's okay. Once it comes to more detailed answer, you can state these other examples and so on and so forth. But it's just asking what's an operating system. So you have given very high level. That's good. Why we need an operating system? Allows you to communicate with the computer without knowing how to speak the computer's language. Well, ambiguated. Why it's operating system? That's ambiguated. We can't use computer without operating system. Yeah, that's not something that we require. You should state what are the missing features. Operating system is the interface between the system hardware and system software, system hardware, and the user. Right. So not sure. It manages computer memory process as well as hardware and software. So this is kind of a good. Why we need it's a management component in computer resources. It manages the computer resources such as memory, input, output, processing, and so on. So got the point? What are the good answers and bad answers? It oversees computer memory process as well as all of its software and hardware. It also allows you to communicate with the computer without learning how to speak computer language. A computer is worthless unless it has an operating system. Well, now it's like it's overall like for a documentation. If you are teaching to someone else, this kind of a thing is fine. But when it comes to answering, the reader is much having good understanding. This is not someone you are going to teach to a person who don't know anything. There's a difference between. If you are going to teach someone who don't know anything, you have to start from very beginning and build up it accordingly. But once it comes to answering, you are trying to give an answer for some sort of educated or well-known audience. So you can take that advantage instead of writing a lot. Overall, okay, the expected answer is around like something like manage these kinds of things, operating system, and it's an intermediate layer between. In some cases, what happens without operating system? What happens without installing a computer? Can we use? If the case is we can't use, why we can't use? What are the missing pieces? You can specify. We can't install software. There's no hardware drivers can be a place to install. So those kinds of like very detailed answer you can give if you have time. What do you mean by I/O devices? I/O devices, any process program or device transport data or from a computer. Examples are printers, blah, 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 blah. So these are like common I/O devices, input and output devices. All right, I think that's quite easy. It's a peripheral that transmits input to output from the CPU process. CPU, okay. Well, good. Overall, good and explanations are there. All you should state. It's mainly something that for input and output. You can provide examples all the time, then your answer might be more stronger. What do you mean by instruction? Provide an example. Here, a computer instruction is a command issued by a computer program to a computer processor. At its most basic, the instruction is a series of ones and zeros that presents physical process the computer is to carry out. Yeah, well, acceptable. So, any example? No answer. Example given. In such cases, you might lose some marks. See, asking two questions. What do you mean by instruction? Provide an example. You have state, okay, this is an instruction, but as an example, there's no example. Here we'll take the question answer number 2. It is simply an order given to a computer processor by a computer program or a live web. Well, okay. Example during presentation. All right, very high level. Good. Now, once it comes to instruction, if a user is going to shut down or terminate something, kill something, it's an instruction. So here it's more technical answer. An instruction is a set of codes that the computer process can understand. The code is usually ones and zeros or machine language. Example, load. Now these are instructions. Now I'm not going to speak about these instruction sets and other stuff, but if you really interest, you can learn about these things. It's much not much towards business, it's much towards to computer science. So I don't want to bias onto the context of computer science. I'm like intermediating these two layers, computer science and business. So for a business student, it might not require to be more detailed like this, but this is something expected. Very good answer. Now, uh, well, one student don't know, no worries at all. Right? Somehow your attempt is very important. Now, a set of codes computer processor can understand. It's just something that you can understand. Sorry, computer can understand. Simply, it's ones and zeros. Set of ones and zeros. Somehow, even it might be a mouse like mouse movement. There are set of instructions are given. You can take an example, very simple example. Your mouse is moving or touchpad. Your touch from one location to another location. Your mouse is going to move. It's an instruction. There are a lot of it's not a one single instruction. Series of instructions are you are giving. Got it or not it? Right. All right. Got it or not it? Liveware means there's a question. What is liveware? Liveware means the people that using this computer, humans. Liveware means human, a person who is going to use the computer. That's all. All right. Somehow, good attempt is very good. Really appreciate your effort. We will go to the slides, right? And we'll go these questions. Question done. Why do we need an operating system? This is your computer. This is your hardware. This is your liveware. It's a dumb device that can't do anything. So this hardware is working after installing the operating system. What's an operating system? So it's on top of the story of this hardware works and software can be installed. It's an interface between applications and hardware, or the users and the hardware, or whatever the stuff that you are doing. Why we need an operating system? Because it's an interface between applications and hardware. Without the operating system, we can't perform much things. As an example, if we want to install browser, player, or any other stuff, it's mandatory to have an operating system. Simply, operating system exploits make full use of, right? But exploit. I just the meaning exploit the hardware resources to provide a set of services to system users. System users are nothing; it's just set of people. IO devices, the hardware device that accepts user commands or input devices such as microphone and output from the computer such as sound, video, etc. An instruction, it's just a command. It's just a command that we are issue to the computer. Computer itself, there might be a lot of commands or instructions issuing to get some work done. All right. Well, that's all for the revision. Let me go to the lesson back. Ah, there's an important announcement regarding your video presentation. I have added the list and the instructions in the to the model. So please go through these instructions. If something you can't understand, always you feel free to back to me and clarify anything you have. Don't make any assumptions because sometimes students are coming back and telling. So I thought, I just assume, I just thought about, okay, it will be something. But please don't perform that kind of assumptions. Always discuss with me and clarify. You can discuss with your uh, leads as well as the students reps are there. Whatever the medium, you can drop an email, telegram message, or any other mechanism. You can tell me if something not clear or something needs to have more detail. Yeah, there's a question. Sorry, I could not today two questions because it mentions. No worries, no worries. I'll sorry, I have disabled the yeah, yeah, I'll enable it. Yeah, now you can send the responses. No worries. All right. Let's see my screen. Not still. Little bit more detailed about processes. First of all, there are a few terms that you should understand. A shared memory, because when it comes to processors, you should understand these key terms well. Here, a shared memory. What do you mean by shared memory? We'll get an example. Now, this is your web browser that uh, executes its programs. But simply, you just click or double click your browser icon. Now it's open in your screen. Now think a situation. In any case, this is your primary memory, your 8 GB RAM simply. If this browser is trying to access entire 8 GB, what could be happen? It's a big mess. It's a big mess, isn't it? Now your browser is going to access entire 8 GB throughout the 8 GB here and there. But actually we don't want. For some reason, we'll think it's going to access 8 GB without any idea. All right, I just enjoy anywhere. It's a big problem. Why? Once it comes to another compute, another process, another set of processes to be executed related to uh, music. As an example, you have opened your VLC player. Now you are enjoying another. You are enjoying music. You are browsing and you are enjoying with music. These are two things that you are doing parallelly. First one and the second one. Now these two activities happen parallelly. Hence, what you should do, you should split your primary memory, your RAM. You should divide the RAM into different portions. This 8 GB can divide 4 GB for the browser, 2 GB for the music, and 2 GB remain as it is without any use. If anyone arrives, another new process arrives, we can allocate this 2 GB. Got the point? That's the meaning of this shared memory. You have shared the memory. You have shared whatever the information. Now, it's not actually two. There might be hundreds of processes are running parallelly. I just given very high level understanding about this, but don't think it's just one. Your browser consumes 4 GB. I just given an understanding, or what, I just given some example to you to understand what is that. It's a shared memory. The memory shared among number of processors or simply number of applications. For your understanding, it's more than enough to number of applications are running. to have these kinds of applications. What I have done, I just executed everything. But my processor has, sorry, my RAM has specific space, it's 8 GB. So what I have to do is I have to divide it into different parts. How to divide into different parts? That's the concept of shared memory. There are different algorithms, different approaches available to perform this kind of sharing, how to perform this sharing and other stuff. But high level, this is the concept of shared memory. Bootstrap program or bootstrap loader answers even from this bootstrap. This is the initial program that executes when the computer power is on, or once there's a restart or a reboot. Whenever your computer is going to restart, or your computer starts at the beginning, at the very first time, the processes. Yeah, well, think a situation. You just press your switch on button. That's all. A lot of things behind the scene happen. Lot of the things. You just waiting for sometimes few seconds, sometimes few minutes, depends on your computer architecture and data availability, processor and other stuff. Sorry, not the data availability, the resource availability. It depends, the times depends, but every computer follows a set of instructions, a set of things. This bootstrap program or the bootstrap loader is focused on this initial execution. Why? The operating system is a software that is located in the secondary memory. It's stored in the secondary memory. That also stored in the secondary memory. Now, once you switch on, once you press this your power on button, there should be a set of instructions execute before loading your operating system. Do you got the point? අපි switch on button එක, අපි power on button එක click කරනකොටම operating system එක load වෙන්න කලින් activities ටිකක් වෙන්න ඕන. If not, operating system can't load because operating system has no idea there's a power. It's just a software, another software. It's another software. You got the point. Now, this bootstrap program is responsible to awake your operating system and grant the responsibilities. Hey, I have wake up you. You continue the rest of the things. You continue the rest of the things. If your bootstrap program is so bootstrap load is not working, there are a lot of power on self test and other stuff. I don't want to go that detailed. I'm scoped down this discussion to the operating system. Operating system starts after this bootstrap loader starts. Now, if someone asks, Machan, operating system is the first one, the loading into the computer, isn't it? You should say no. Operating system even keep quiet until the bootloader starts. Bootloader should provide instructions to the operating system. Hey, you have to continue the rest of the things. I have started required stuff. Now it's your responsibility. Now bootloader's responsibility is to awake the operating system, because bootloader is the software, the piece, the specific piece that it's a ROM, right? It's a read on memory. It's a ROM. So it knows where the operating system located, where it's stored. Okay, it's as an example, if you want to awake a guy who is sleeping somewhere, we should know where that guy is currently sleeping. Then we have to go to that place. Hey, we have to ask that person to wake up. Okay, that's the story of this bootstrap loader. Got the story or not? Clear or not? Interrupt. What's an interrupt? This is responsible for relevant task to execute by interrupting relevant hardware call. What is this? Now, there is a situation that we want to disturb. We want to disturb. Why? For some reason, we can't allow to move as it is. Now, what happens in this current political environment? It's an interrupt. It's not allowed to perform the standard political situations, political things. Go home and other stuff. People are shouting here and there because they want to interrupt the current flow. Why? There's some issue in here. There is some issue in here. People don't accept. That's why they have started interrupting. There might be a fuel crisis, electricity, power, gas, and a lot of issues are there. So people start interrupting. They have interrupted the business, they interrupting the government. Similarly, in any case, like data is not moved from one location to another location, or the processor could not accept the sufficient inputs. In such cases, there are interrupts. Anyone can tell me, we found this term in somewhere previously. Where? This term we have seen the same term in somewhere. Can someone tell what is that place? Power. Oh, well, related to process diagram, operating system process diagrams. Can you remember? There's a word given in there. There's an interrupt. Can you remember? Are your requirements here somewhere like that? So there's an interrupt. The operating system flows is getting interrupted. So I can't run it further. I have interrupted it. You go back. These interrupt calls are responsible to interrupting relevant hardware call. All right. You interrupt. You are going to destroy your process. That's all. System call or a monitor call requesting a service from the OS kernel which is required to execute. Simply, this is a service that we want to perform. What do you mean by kernel? Anyone? What do you mean by a kernel? No idea. Simply, the kernel is the core component in an operating system. It's the core component. Almost the most required functionalities are executed or written in kernel. This kernel has highest power. So what you seen at the moment, we can't see actually the kernel as it is. It's set of codes, that's it. It's not a hardware component, it's just set of codes again. After grab this OS kernel, we can perform number of modifications and provide another output as another software or another operating system. Most of the part, we don't modify the kernel. We keep the kernel and we do the modification for the rest. As an example, there's a Linux kernel. There's a Linux kernel. On top of this Linux kernel, we are developing or created number of flavors, such as Ubuntu, Kubuntu, Fedora, so SUSE. So all of these are using a single same kernel. Same kernel, Linux kernel is in there, but There are different UI functionalities and other stuff. Got the point? Now that's an operating system kernel. So whenever some service required by the kernel required to execute, that's known as system call. CPU interruption. When the service interrupts the CPU execution, then the CPU immediately moves to the starting address where service routine of interruption is located. I think these might be a little bit advanced. So at the first glance, you might unable to understand what is this? I can't understand anything. All right, that's usual. So if you have gone through the previous things, documents that I have given, and the references that I have given, and if you spend few hours for this subject, I don't think so it's a big deal, you can understand. But if it's the first day that you are uh, going through with these concepts, quite hard at the beginning. That's usual. After few times you are going here and there, you might be able to understand. But don't worry, you hang on and try to understand up to some extent, at least 30 to 50%. Then the rest of the things you can build in your free time somehow. What's an CPU interruption? When a service interrupts the CPU execution, when in any case the service is going to interrupt the CPU execution, what happens in here? CPU would not perform further, so it moves back to the starting address. That is the place that service routine of interruption is located. Right? That's the place. Now, if we get an example, now think we'll get a real world example to understand, but this is not a best example to describe the same situation, but generally understand. This interruption is like this. Now you are going from your home to Colombo. There's a protest in somewhere, right, near to Colombo. There's a protest. So this is an interruption. So it's an interruption. So what you do, you can't go to Colombo. What you do, you move back to the address that you originally located, which is your home. You back to the same place. Similarly, what happens in the computer, same thing. If there's something corrupted, something broken, there's an interruption, it can't move further. So what happens? It moves back to the address or the same place that it initialized. The interruption is located, where the interruption starts for some reason. It's basic. What are single processing systems and uni-processing systems? Only one processor means it's a single processing systems. Systems which allows one processing at process execution at a time. Sorry, single processing systems, that means, sorry, it's not multi, it's uni-processing systems. Same word, single processing systems or uni-processing systems means only one processor. It has only one processor. System which allows one process execution at a time. No parallel execution. Parallel execution means having one or more things in same time, simultaneously. There's no simultaneous execution. Now we'll get an example in here. Well, you are running from here to here, and parallelly there might be another guy who is running. In such case, it's not a uni system, uni processing. It's not a single processing. Now we'll take this guy to here. Now you are running for a while and asking, but we'll think you are hanging a pot or something, a mobile phone or something. Then you took this one and running up to some extent, then asking the rest of the guys, okay, please carry up to the in place. Now this is a uni-processing system. It's a single process. In this case, this is a uni-processing. A single process continues. There might be multiple interactions, multiple things can happen here and there, but this is the situation of moving. Inter-process communication. This is the communication between two processors. Now, I think you got what's a processor. Now, there are multiple processors can execute at the same time, parallelly or simultaneously. Now, these two processors are running. Now, they should communicate in between them, that is known as inter-process communication. The processes can synchronize their actions without using same address space. Common methods are shared memory and message passing. So I think you know about this one now. Shared memory, you know about this one. Message passing will other things. So require some more knowledge, but you just try to understand what is this, what is happening in message passing. Somehow, I just want to give essential component. What is that? It's a situation that communicate between two processes. Now, we'll get an example. These are not perfect examples, but something to understand. Something is better than nothing, isn't it? So something to understand. Now you are watching a movie. Now, this is, we'll take you are watching a movie. Now I have expanded the hours. This is the time 0. This is, we'll take it's 20 minutes lengthy video. This is the video, the image, the people are dancing and walking here and there in this screen. And this is the audio file. This is the place that audio execution. Now, what is the most requirement thing? Most requirement thing is communicating in between these. As an example, time 0, both, you know, these are still images, isn't it? A series of still images. So this screen should exactly match with this audio. And further, if there's more than that, there's a subtitle, it should be exactly matched with this one. Unless something you can't like you can understand the person spoke, and after a while the voice is coming out, or some another subtitle is called. I think you have these real world examples. Now, similarly, if it happens in a computer, it might be a big problem, isn't it? There's a Hindi movies running in here, and subtitles are something like totally different from a different movie. I don't know whether you have this experience or not. I have this kind of experience. We can't allow this kind of process communication. So what happens? We are providing a proper mechanism for inter-process communication. We have this one with this timestamp. So whenever this starts, that means you are going to start with this one. And this, if this one, there's a voice or a subtitle, it has a specific time slot. So that means if we divide into very small components, there are a series of situations are there, a series of threads are there, or process threads are there. So what happens? These process threads are communicating with each other. Like there are two guys walking. Another example, there are two guys walking. All right, they do not speak each other. Right, they do not speak each other. I think now these two are getting angry now for some reason. They are not friends. They are enemies. And there's a vehicle. This vehicle is trying to have a collision with this guy. There's an accident within next couple of minutes. There's no communication at all. Then this guy will have a collision and get accident and die. If there's a process communication, if these two guys are walking together and having a proper communication, that means what happens in here? If some accident is going to happen, this person can shout, hey, there's an accident. So this guy will react. That's the importance of intercommunication. Right? Intercommunication. This one spoke with this one speaking with this one. It's an inter-process communication. It communicates among them. For a success output. If there's no successful output, then no point at all. If there are multiple processes are executing in the same time, that's the reality of this step process communication. Process scheduling. Now, what was process scheduling? We have to schedule a process. We can't let everything happens as it is, right? As it is. What is this? Processes process has all necessary resources which required for execution for that process when CPU is allocated. Process is ready for execution but waiting for the CPU to be allocated. And this one is ready, almost. All right, I'm ready. I'm going to execute now. Execute now. Similarly, this is process scheduling. There's multiple processes are there. Multiple, lot of hundreds of processes are ready. It completes all the requirements to be executed. But the processor can process one instruction at a given time, only one instruction at a given time. So what we have to, there should be a component that handles who is going to next, who is going to next. This person is known as this process scheduler. Schedules, you go next, you go next, you go next, and so on. So what's the concept of a deadlock? Anyone? What do you mean by a deadlock? Quickly. I will give 2 marks for your final assessment. This in class, sorry, this what we call assignment, additional 2 marks. If you explain it properly, I'll give 2 marks. Deadlock. Yeah, since I got an answer, two processes can't work because both need each resources, but resources are shared by each other. Perfect. Yeah, you got 2 marks. I record your index number. Right. Right. Perfect. Now, what happens in here? There are two processes. Process 1 and process 2. Process 1 and process 2. These are two processes. Now, execute this process. It requires this resource 2. This resource 2. But unfortunately, this resource 2 is already assigned to process 2. So process 2 can't release this resource. Now it's hanged. But process 2 also can't execute. Why? Process 2 requires additional resource, that is resource 1. Until this resource 1 allocated to the process 2 can't execute. But unfortunately, this resource 1 could not allocate it for this process 2 because this resource 1 is already assigned to process 1. Process 1 can't execute again because of this resource 2 is unavailable. How to fix this issue? Any ideas? How to fix this issue? Any idea how to fix this issue? In very simple terms, what we can do, we can delete either this process. We can delete the process. If we kill this process or delete the process, what happens? Then this resource 2 will release. This resource 2 can allocate to process 1. Then this process 1 can execute. Or in the other hand, we can kill this process 1. Then the already allocated resource 1 can be allocated to process 2. Now what happens in here? Process 2 requires 2 resources, resource 1 and resource 2. Now both resources are fulfilled. Both resources are given to the process 2. Now the process 2 can execute without any problem. Resource 1 and resource 2 both. Got the point? I have given very high-level understanding about this law. You should argue the story that I told, process 1 and process 2, killing the processes. Do you agree or disagree? You can research on this. Okay, you can research on this and get an idea about this process 1 and process 2. Killing the process, or any other methodology that we can apply to solve this deadlock issue. All right. Any questions? Anything needs to discuss further? Any questions? All right. Termination of a process. Now, what do you mean by termination of a process? A process can be terminated normally by compiling task to another process or killed by a user. A process can be terminated. All right, it's going to be stopped by completing its task. One situation is I'm going to stop it by completing the task. Or there might be a fatal error or killed by another process or forcefully killed by the user. So you can kill the processes. You can kill the process means you are going to terminate the process. When the process completes its task without any error that exists normally, the process may exit abnormally because of occurrence of fatal error while it's running. The process can be killed or terminated forcefully by another process. There are two situations. One, process successfully completed all the required things. Second, the processes are killed or stopped because of a forceful by another process. Simple. Clear? That's the termination of process. These are quite easy. Failing of a process. If a process is terminating abnormally, then that is a considerable problem. In any type, if a process is failed, the operating system maintains a separate log file. You can find these log files and you can do some what we call But I don't think so. For your students, you don't want to go for this kind of very detailed log analysis and other stuff, because there are people who are for performing these configurations and detecting error detecting processes. So we keep quiet. We don't want to go for that. All right. Any questions up to now? Any questions? No questions? All right. There's something like I want to specify regarding your documents. Except one team, all of your teams are selected one human architecture. That is quite easy and quite basic. So in that case, you should do some additional work. Now, the teams who selected one human architecture might good to select another topic too and present that one. All right. Only one or two teams can, one team I think can present about this one human, or no, sorry. We'll do like this. Uh, for the presentations, you have to select any other topic in class presentations. In class presentations, you should select any other topic than one human. Got the point? For the presentations that you are doing the recordings, then no worries. You can do one human with the topic that you are doing in class. But for the in-class presentations, none of the team can use one human architecture. I think that makes sense, unless I think it might be quite boring. Everyone is going to present one human, one human, one human. It might be boring, right? Representatives, any idea to distribute other topics, or we'll let them to, or group leaders? What is your idea? You can discuss with your team and select a topic rather than one human. You can present it in the recordings, but not in the class presentation. In class presentations, none of team should present von Neumann architecture. All right. No point to discuss this von Neumann architecture. I think you already, everyone, most of you having von Neumann architecture in your head. We'll do it later on, but or else I'll do that presentation. All right, I'll do that presentation instead of your teams. I think that's better. You have to select another topic, not von Neumann. The one team, one of team, I can't remember. Turing machine or something. Turing machine or automata. I can't remember. Some Turing machine, if I'm not mistaken. Your team, no worries. You continue your presentation. Others, please discuss. No, each and every team should select another topic instead of one new one. Okay, clear? Unless it might be quite boring, isn't it? It might be quite lazy. One new man, one new man, one new man. Everyone is telling one new man, one new man, one new man. Right? It's quite. It's not something interesting. So you have to select another question and your presentation. No need to write it. No need to add the document. Your document can continue one new one. No worries. And but for the in-class presentations, it's mandatory to select any other question than one new one. Got it? Clear? Any questions? Yeah. I mean, for the in-class presentations, none of you can present one Neumann architecture, one Neumann question. Okay, you now already if you have selected one Neumann, you can continue the documentation for the one Neumann, no worries. And if you want to add this presentation for the video presentation, no worries. But for the in-class presentation, you should select something else than one Neumann. None of team can present about this one Neumann question. Yeah, sure. You can use the same topic for the report also. No worries at all. We'll do something for the draft. No worries at all. In-class presentation can use one, and for the what we call group presentation, that the recorded presentation, you can do another one. That's okay. Then 2 questions will be answered by each team. You need 2 leaders for 2 topics for the 2 reports. Well, that's good. That's a good idea. Yeah, that's a good idea. In any case, if you are creating another set of leaders, please let me know. Then I can add another marks for the second leader, for the second topic. But that, not that one, we'll do something else. In-class presentation, it's a group. In-class presentation, come on, you didn't get the question that I'm telling. In-class presentation is extract same questions are going to be present. The only condition is you can't use one Newman question. Instead of one Newman question, you may select any other question and do the in-class presentation. It's a group presentation again. And you can use the same information for the report too. Or else you can use one Newman as a presentation and recording and upload it. No worries at all. For the documentation, one Newman is okay. But for the in-class presentation, you should not use one Newman question. Any other questions? You can decide that presentation, no worries for the in-class presentation, you mean? Or the recorded presentations. I have given a space for the recorded one. I have given a space in the Moodle. You can upload to there. All the deadline and stuff in there. If you want couple of days more extended, I can do it now. Check and let me know. Do you want more time? Your answer is obviously yes. I know. If that comes, your answer is yes, sir. Please, another at least 1 hour would be worth for us. But all right, I know that answer. I know that answer, but if you can complete within that time, I think that makes our life easier. Well, presentation deadline is 6th of July. It's more than enough. 11 days and 8 hours, so no need an extension. So 11 days is for 5 minutes presentation. 11 days is more than each one can present it. Any other questions? Any other thing you need to discuss? Representatives, please the students who do not attend today lecture, please inform them, and team leaders, it's your responsibility to make sure to drive the team for success. In any case, if you are giving the leadership for one activity, another one can propose as the second leader, and please inform that you are giving the leadership for this kind of thing. Drop an email, then I will keep a note on that. All right, if you want to create another leader for the second one, if the first leader is having a lot of work, you can choose. There's a question, if we choose a topic other than one Newman, can we use the topic for both the in-class presentation and recorded presentation? Yes, of course, you can. Any other questions? Group leaders, please drop an email, or else we'll do like this. I think I will create another column for the in-class presentations. Do I require it? Yeah, it's required. Now, unless everyone will select Turing machines. All right. Maximum, what we call, maximum 2 teams can use one topic. All right. Maximum 2 teams can select a topic. In class presentation topic. All right. Only 2 teams can use one question. Okay. You have to mention what is the question that you are going to use. One Newman is strictly prohibited. Your one Newman. Any other question? Team leads discuss with each other and come up to your topic or come up to your question. Maximum 2 teams can present one topic. Maximum 2 teams. Question 1, 2, or 3 you can update in here. Right. Update in this place, in the sheet, in the Google sheet. If you have a topic, you can update now. You can update later on with your friends. Okay. Thanks. Already, Sandani. Yeah, that team number 2 updated with Turing machine, and team number 3 already updated with the question number 2. Good. I think updated in another place. Should be updated in here. All right. Already 2 done. Other teams discuss and update in the proper column. All right. You can discuss it and update it in here. Probably today itself you can finalize. If any case, if there are more than 2, I will delete both of teams. Right. So make sure to update properly. Now already 2 teams are selected, so you can't disturb to them. You can select any other question and create presentations, perfect presentations, images, slides should be very perfect, professional, elegant, smooth transitions. Make sure to have proper connectivity. If your place currently having like connectivity issues, personally there are connectivity issues, leave your place and move to a place that having good strength, your aunt's home, uncle's home, or any other place. If your home is not strong enough, sacrifice for a few hours and give the maximum contribution to your uh, team, because it's effect for the entire team. If you got one human, you can't, I told it properly, Uresh. All right, please don't use one human for the in-class presentation. මම කියපු දේ පැහැදිලිද දරුවනේ? one human ප්‍රශ්නේ ඇර අනිත් ඕනම ප්‍රශ්නයක් ඕගොල්ලන්ට in class presentation එකට අරගෙන කරන්න පුළුවන්. one human ගන්න බෑ. ඔයාලට one human කරන්න ඕන රෙකෝඩින් එකට දාන්න, අප්ලෝඩ් කරන්න one human document එක හදන්න ඒක issue එකක් නෑ. හැබැයි one human in class presentation එකට ගන්න එපා. Clear? All right. Any other questions related to today's discussion? You can discuss with your team and update the topics later on. No worries. Any other questions that you want to discuss today? Well, there are questions. Yeah. So to recap, if we did report on one human, we can record and upload present for it. Yes. And then do different question in class. Yes. Yeah, Mayudi, your thought is correct. All right. If you don't have any questions, yeah, well, no questions, isn't it? Yeah, well, that's it. So I think you don't want to hang with these hardcore theories further. I know it's a bit terrible experience. So no worries. We'll meet next week and continue the discussion. And I believe everyone will prepare well for the presentations. I expect outstanding presentations. Present well, clearly, prepare yourself, speak 10,000 times, and prepare yourself. Your slide should be clear, detailed enough. It's a PowerPoint, so please don't add lot of text load to your PowerPoint. It should be like points, the most powerful points that you are going to add, but a short description is allowed. But please don't add essays. Please don't add essays. Please don't add unwanted gifs, unwanted emoticons and other stuff. Make sure to present it properly, clearly. Your background should be clear for the audience, and whatever the stuff that you are going to present, it should be clear for the audience. It's not something easy. It's not something easy to speak for an audience with a different knowledge levels, different levels of people. So it's your responsibility to entertain at least 70% to 80% people. You can't integrate 100 out of 100. There's no possibility. No one can do. At least above 60 should understand what you are speaking. And for the questions, every team should ready for a question. As an example, now to next day, team 1 going to present. So 2, 3, 4, 5, 6, 7, and 8 should ready. Each team should ready one question to ask from the team 1. If that questions are quite easy, what I'm going to do, I'm going to ask a question from you. All right. Any other questions? There are about 7 assessments given for us submit. What? There are about 7 assessments given us to submit within these days. Okay, then I have given 7 assessment. No, I have given only 1 assessment. Something gone wrong, Puta. I haven't given 7 assessments. Aha, the subjects. So personally, I have given for the entire semester 1 assignment, isn't it? What to do? I have given only 1. For my subject, I have given 1. So I can't make it 0, right? Isn't it? I can't make it 0. I have given only 1 assessment, 1 report, and 1 presentation. That's it. The presentation is in class. That's it. And it's a group assessment again. It's not an individual. So I think I have given maximum support for you to complete other assessments. But I have to do an assessment. It's one of mandatory requirement. Unless I can give random marks to you like 5, 10, 8, and other stuff. What do you think? 3 out of 25. No need to create 2 presentations. You can create 1 presentation and do in-class presentation and record it again and to upload it. That's it. If you really worry about these presentations again, I'll remove that one. What do you think? If you feel it's hard to record it again, I'll remove that one. What do you think? Shall I remove that one? That component? I'll allocate the marks for the in-class presentations only. Why I have given these 2 is because if there's like latency and other stuff in worst case, if some of students got some latency, unfortunately for some reason, then that student gets 0 marks for the presentation. So that's a big problem, isn't it? That's why I have given. Yeah, sure. You can do the presentation. But we choose we make another presentation. Of course, you should create another presentation apart from one new one. Access is given for all the questions. I think you can download it. Anyone can't download the questions? I have given the access for all the questions. You may download you may find these questions in the Moodle, isn't it? Yeah, here it is. All the questions are in one place, so no need specific access. ඔක්කොම ටික තියෙන එකම තැන දරුවෝ ඔක්කොම questions ටික ආයේ විශේෂයෙන් access ඕනේ නැහැ මට අමතකුණා මම අර MIS කට්ටියට තමයි documents දුන්නේ වෙන වෙනම questions ඔයගොල්ලන්ට දුන්නේ එකම තැනනේ පොඩි questions ටිකක් දුන්නේ ඔයගොල්ලන්ට first year හින්දා You can't argue with anything. It's a decision, that's it. Any other questions? All right. Well, and get ready for the presentations and good luck, and ready for the presentations well. And if any case, if you want further help, I haven't shared the Telegram group. Is that so? I have shared, right? Telegram group. Telegram group. If you want to connect in here, you may connect. Yeah, I think that might be good. Everyone in the meeting, right? All right. I have shared the Telegram group link also. Please join with that link. If you want some informal communication with me or with your teams, I highly encourage you to communicate it. Okay. If you have any questions, feel free to contact me and clarify. If you want any further help, if you want any comment or give us some sort of high level review regarding your presentations, you can share it with me. I can give some sort of comments, whether good or bad, likewise kind of things I can give before the presentation. And three groups will be present next week, and we all expecting some very good presentations. And apart from the presenting group, each team, please make sure to ask a unique question from each team. As an example, if team 1 is going to present during the class, the rest of teams 2, 3, 4, 5, and 6 and 7, each group should ask one question, at least one question from group 1. So altogether, there might be 7 questions should be answered by each team. Okay, so ready for, like, what are the things that each team is going to present. Now the top question is in the Google Doc, so easily what is going to present by each team. So you should ask a question, or while doing the presentation, if something get confused, you can ask from the presenter, what is that, clarify it. All right, clear? We'll take around 5 to 10 minutes Q&A session. Not a big detailed. Clear? That's it. All right then. See you. Bye. We'll meet next week with an amazing presentation. See you. Bye bye. We'll meet next week.